Hello and welcome to this video on exemplified read-through of the Postgres documentation. In the last video, we started the data formatting functions and we saw an example as well as cover half of the theory. So in this video, we will finish the theory. We had read till here, here. So we'll finish this quickly and we'll wrap this video in short amount of time. If you have not watched my previous video in this playlist, make sure you go ahead and watch that video. Otherwise, it is kind of difficult to understand what is going on. So with that out of the way, let's get ahead with our read through. In to underscore timestamp and to underscore date, the YYYY conversion has a restriction when processing years with more than 4 digits. You must use some non-digit character or template after YYYY. Otherwise, the year is always interpreted as 4 digits. For example, with the year 20,000, to underscore date, and with this date 20,000 30th November, and YYYYMMDD will be interpreted as 4-digit year. Instead, use a non-digit separator after the year like to underscore date 20,000 hyphen 1130 YYYY hyphen MMDD or to date 20,000 November 30 YYYY month DD. In to underscore timestamp and to underscore date, the CC century field is accepted but ignored if there is a YYYY or Y comma YYY field. If CC is used with YY or Y, then the result is completed as that year in the specified century. If the century is specified but the year is not, the first year of the century is assumed. In to underscore timestamp and to underscore date, weekday names or numbers day, comma D and related field types are accepted, but are ignored for purposes of computing the result. The same is true for quarter field. In to underscore timestamp and to underscore date, an ISO 8601 week numbering date as distinct from a Gregorian date can be specified in one of two ways: year, week number, and weekday. For example, to underscore date 2006-42-4, and the template is IYYY minus IW-ID, returns the date 2006-10-19. If you omit the weekday, it is assumed to be 1, that is Monday. Year and day of year. For example, to underscore date 2006-291 IYYY-IDDD also returns 19th October 2006. Attempting to enter a date using a mixture of ISO 8601 week numbering fields and Gregorian date fields is nonsensical and will cause an error. In the context of an ISO 8601 week numbering year, the concept of a month or day of month has no meaning. In the context of a Gregorian year, the ISO week has no meaning. We have a caution: while to underscore date will reject a mixture of Gregorian ISO week numbering date fields, to-char will not, since output format specifications like YYYY-M-DD or IYYY-IDDD can be useful, but avoid writing something like IYYY minus MM-DD. That would yield surprising results near the start of year. So we'll see section 9.9.1 for this information. Let's see, go there. So this is much later. Okay. So let me pull that. We were doing data type formatting. It does not have a back button like browsers, because it's a PDF. Okay. So there it is. In 2_timestamp, millisecond or microsecond fields are used as the second digits after the decimal point. For example, 2_timestamp 12.3 and format specifiers are ss.ms is not 3 millisecond but 300 because the conversion treats it as 12 plus 0.3 seconds. So for the format ss.ms, the input value is 12.3, 12.30, and 12.300. Specify the same number of milliseconds. To get 3 milliseconds, one must write 12.003, which the conversion treats as 12 plus 0.003, that is 12.003 seconds. Here is a more complex example. 2_timestamp 15 colon 12 colon 0 to dot 0 is 15 hours 12 minutes 2 seconds 20 milliseconds 12:30 microseconds. 2char ellipsis comma id is day of week numbering matches the extract ISO day of week from function, but 2char from specified d does not match extract date of week from days numbering. 2_char interval format HHN is 12 as shown on a 12-hour clock. For example, 0 hours and 36 hours both output as 12, while HH24 outputs the full hour value which can exceed 23 in an interval value. So this table shows the template patterns available for formatting numerical values. Pattern 9 is digit position can be dropped if insignificant. 0 is digit position will not be dropped even if insignificant. Dot means decimal point, comma is group separator in thousands. PR is negative value in angular brackets. S is sign equal to number. L is currency symbol. D is decimal point. G is group separator. So these are governed by locale. Okay. So decimal points in some notations is basically a comma. MI is minus sign in specified position if number less than 0. PL is plus sign in specified position excuse me, if number greater than 0. So this bad. SG is plus or minus sign in specified position. RN capital or small is Roman numeral between 1 and 3999. Capital TH or small th is ordinal number suffix. Capital V is shift specified number of digits. Quadruple A is exponent for scientific notation. Then we have notes for numerics. 0 specify a digit position that will always be printed even if it contains a leading or trailing 0. 9 also specified a digit position, but if it is a leading 0, then it will be replaced by a space. While if it is a trailing 0 and fill mode is specified, then it will be deleted. For 2_ number, these two pattern characters are equivalent. If the format provides fewer fractional digits than the number being formatted, 2_char will round the number to the specified number of fractional digits. The pattern characters S, L, D, and G represent the sign, currency symbol, decimal point, and thousand separated characters defined by the current locale. The pattern characters period and comma represent those exact characters with the meanings of decimal point and thousand separator regardless of locale. If no explicit provision is made for sign in 2char's pattern, one column will be reserved for the sign and it will be anchored to appear just left of the number. If S appears just left of some nines, it will likewise be anchored to the number. A sign formatted using SGPL or MI is not anchored to the number. For example, 2_char -12 MI 9999 produces hyphen, then we have 2 space 12. But 2char -12 S 9999 produces -12. We don't care about Oracle implementation. TH does not convert values less than 0 and does not convert fractional numbers. EL, SG, and TH are both with SQL extension. Into underscore number, if non-data template patterns such as L or TH are used, the corresponding number of input characters are skipped, whether or not they match the template pattern, unless they are data characters, that is, digits, sign, decimal point, or comma. For example, TH would skip two non-data characters. V with 2 underscore char multiplies the input values by 10 to the power n, where n is the number of digits following V. V with two number divides in a similar manner. The V can be thought of as making the position of an implicit decimal point in the input or output string. 2 underscore char and 2 underscore number do not support the use of V combined with a decimal point. For example, 99.9V99 is not allowed. Quadruple E is scientific notation, cannot be used in combination with any of the other formatting patterns or modifiers other than digit and decimal point patterns, and must be at the end of format string. 9.99 quadruple E is a valid pattern. In two number, the Rn pattern converts Roman numerals to numbers. Input is case sensitive, so R, capital Rn and Rn are equivalent. Insensitive. Rn cannot be used in combination with any other formatting patterns or modifiers except FM, which is applicable only in 2 underscore char and is ignored in 2 underscore number. Certain modifiers can be applied to any template pattern to alter its behavior. For example, FM 99.99 is the 99.99 pattern with the FM modifier. Following table, that is this table here, shows the modifier patterns for numeric formatting. We have FM prefix, it is fill mode, suppressed trailing zeros and padding blanks. TH suffix is uppercase ordinal number suffix. Small th is lowercase ordinal number suffix. Now we have some example and usage of 2 underscore char function. We have 2 underscore char current timestamp, and we convert it to day comma dd hh12 colon minute colon second, and it is formatted like this. Then we have another example. In this case, dd has become fmdd, fill mode, and hh12 is remains same, the rest of it remains same. You see the spacing has been filled here. Then we have 2 underscore char current timestamp at time zone UTC, and this is the pattern. So this is how it will be formatted. So you can go ahead and look at the examples. There is no point reading these. We have already gone through a lot of examples. So if you want to go through exact examples, I would implore you to go through this on your own and try to understand. If you have problems, let me know in comments, and I should be able to resolve that. So with this, we come to the end of section 9.8, and in the next video, we will start with date, time functions, and operators. So that is going to be an important one because we have to deal with date-time functions all the time. So I hope that you are enjoying this series of videos and finding it useful. Reading documentation can be very fun if you like to go deep, because manual write-ups like of databases or programming languages are very detailed. So there is lots of details. For example, when you read the standard language documentation of any language, you learn a lot. Same with Postgres or any other database. MySQL also has a very excellent manual. So with this, I will end this video here, and we will meet tomorrow again with another video on date time functions and operators. So I will say bye and take my leave, and you have a nice day and take care.